Okay, in this lesson, we are going to learn about the rational root theorem. This is page 9 in your notes. We are going to use the rational root theorem to determine possible factors and then apply synthetic division to find all roots of a polynomial. So there are different types of roots. There are rational, irrational, real, and imaginary. So when you get a root that is -3 or +1/2, these are considered rational roots. When you get the square root of a number, these are not rational, they're irrational. Or you could have imaginary roots. We're going to talk about the rational root theorem. So it's not going to find these possible values. It will only find the nice whole number or fraction values that could be possible roots. So the rational root theorem says that it's the possible roots of a polynomial. They won't all be roots, but it's the possible roots. So you do plus or minus the constant on the end of the polynomial, all of those factors, divided by the leading coefficient, all of those factors. So in this example, it's plus or minus all of the factors of a sub o divided by all of the factors of a sub n. Last year, you might have learned it as plus or minus p over q. Same thing. So in our example, you're going to find the factors of the constant on the end, 8, which that would be 1 times 8 or 2 times 4, and those are the only possible ways to multiply to get 8. And then we're going to find the factors of the number 4, our leading coefficient. So to multiply to 4, we could do 1 times 4, or we can do 2 times 2. So we're going to do plus or minus these factors from least to greatest. So plus or minus 1, 2, 4, and 8. And we're going to divide it by these factors. Now because 2 is written twice, I don't need to write it twice down here. So it would just be plus or minus 1, 2, and 4. Now comes the fun job of dividing. So we're going to start by dividing all of the numbers on top by the number 1. So 1 divided by 1 is 1. It's plus or minus. 2 divided by 1 is 2, plus or minus. 4 divided by 1 is 4. And 8 divided by 1 is 8. Now we're going to divide all of the numbers on the top by 2. So 1 divided by 2 is a half. 2 divided by 2 is 1. Notice we've already listed that as a possible factor, so we don't want to list it again. 4 divided by 2 is 2, and notice we've already listed that as a possible factor. And then 8 divided by 2 is 4. We've already listed that as a possible factor. We don't need to list it again. Now we're going to divide all of the numbers on the top by 4. So 1 divided by 4 is 1/4. 2 divided by 4 is a half. We already have that. 4 divided by 4 is 1. And 8 divided by 4 is 2. So those are all of the possible roots of this polynomial. Just a reminder, we learned about this a couple days ago. The remainder theorem says if x minus k is a factor, then f of k equals 0. Meaning, if we have a possible factor, we could plug it into the function and see if we get 0 to see if it will go in evenly. And also, if x minus k is not a factor, then f of k will give you a remainder, meaning you can't synthetically divide by that value because you're going to end up with a remainder. It's not a factor. So taking this last example, let's say we want to test one of the many possible factors. So let's say we decide, let's plug in 1 and see if that gives us a remainder of 0. So when you plug in 1, that's 4 times 1 to the 5th, which is just 4, plus 12 times 1 to the 4th, which is just 12, minus 1 minus 8, which simplifies to 7. That means that 1 is not a factor and it will not go in evenly. So then you'd have to try a different number, maybe negative 1, to see if that will give you a remainder of 0. Okay, number 1 asks us to list all possible factors for h of x equals 4x cubed plus 8x squared minus 9x minus 18. So using the rational root theorem, we're going to list the factors of our constant 18. So what multiplies to 18? Well, we have 1 times 18, 2 times 9, or 3 times 6. Then we need to list our factors of our leading coefficient 4. So what multiplies to 4? Well, we have 1 times 4 and 2 times 2. So the rational root theorem says to do plus or minus these factors. So plus or minus 1, 2, 3, 6, 9, and 18. Notice we write them least to greatest. And we're going to divide it by plus or minus 1, 2, and 4. Notice again, I'm not writing 2 twice. So now we start to divide. So starting to divide by 1 to all the numbers on the top. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. We have 6, 9, and 18. Now we're going to divide all of the numbers on the top by 2. So 1 divided by 2 is a half. 2 divided by 2 is 1, which we already have. 3 divided by 2, that's another possible factor. 6 divided by 2 is 3, we've already listed that. 9 divided by 2 is a new one. 18 divided by 2 is 9, which we already have that one. Then finally we can go ahead and divide by the 4. So we have 1 divided by 4, which is 1/4. 2 divided by 4, which reduces to a half. We already have that. 3 divided by 4 is new. 6 divided by 4 reduces to 3/2. 9 divided by 4 is new. We don't have that one yet. And then 18 divided by 4 reduces to 9 over 2, which we have. So these are all of the possible factors. All right, once you have all of the possible factors, you might be wondering, what is the point of this? If I was to type this equation into my calculator and graph it, this is what the graph is going to look like. We are looking for what the x-intercepts are. So when we're listing this, these are just the possible x-intercepts. So notice it's kind of hard to tell where the graph is going through the x-axis. So this is where you go second table and see what values of x give you a y value of 0, because that is where it would cross the x-intercept. So notice where x is -2, that is in fact a root of the polynomial. So now I know I could divide evenly into the polynomial with the factor of -2. So number 2 says to consider the polynomial equation f of x equals 2x cubed plus x squared minus 2x minus 1. In part A, they're asking us to list all possible rational roots. So this is the rational root theorem. So we start by going to the constant on the end. What multiplies to 1? Well, just 1 times 1. And then you go to the leading coefficient. What multiplies to 2? That would be 1 times 2. So to list all possible roots, you do these factors divided by these factors. So it's plus or minus 1 on the top over plus or minus 1 and 2 on the bottom. So now we have to divide the 1 on top by the 1 on the bottom. So we have 1 divided by 1, which is plus or minus 1. Then we can divide by 2. So 1 divided by 2 is plus or minus a half. So those are all of the possible rational roots. Notice there are 4 possibilities. Doesn't mean they all will work. So for part B, it says to test the roots and then use synthetic division. So in order to figure out which one of these numbers go into it evenly, the quickest way is to use your calculator. So type this function into your y equals, and that will create a graph that looks like this. You're going to have to try to figure out where it crosses the x-axis, but it's actually easier if you just go to the table and you're looking for where the y value equals 0, because that will give you the x-intercept. Notice it happens twice. We have it where x is -1 and where x is +1. This tells you that you can synthetically divide by either one of these because those are both in fact a root. So most of you would probably be thinking, let's do +1 because that will be easier. So we're going to go ahead synthetically divide by that +1 root. So to synthetically divide, remember you write the coefficients of each of these terms. So we have 2, 1, -2, and -1. And we're going to synthetically divide by the root we found with our calculator, which was +1. So to synthetically divide, you drop down the first number. Then the pattern is to multiply, then add. So 1 times 2 is 2. That goes below the next number. And then we add. 1 plus 2 is 3. Multiply again. 1 times 3 is 3. Then add. -2 plus 3 is 1. Multiply. 1 times 1 is 1. Add. -1 plus 1 is 0. Notice you should always end up with a 0 as your remainder because we picked a number that we knew was a factor. So we're going to write this now as a decreased power from x cubed. So instead of it being x cubed, this is going to be 2x squared plus 3x plus 1. We can now t-chart this trinomial. So 2x squared is 2x and x. What multiplies to 1? Positive 1 and 1. Cross multiply, we get 1x and 2x, which does add to the middle term 3x. So since we're solving, we're going to set each of these factors equal to 0 and solve each one. So in the top row, I have to minus the 1 and divide by 2. That gives me negative a half. And in the bottom row, I have to minus the 1 over, so I get negative 1. And don't forget the number you synthetically divided by, which was positive 1. Notice how these two values we found on our calculator, this one was not visible on our table in our calculator. Let's go ahead and try number 3. It says to find all of the real zeros of the function for f of x equals x cubed minus 4x squared minus 15x plus 18. Notice you can't factor by grouping, the groups won't match, so you have to try synthetic division. So instead of going the long way of writing out all of the possible roots, we're going to go straight to our calculator this time. So go ahead, go into your y equals and type the equation in and hit graph. You'll get a graph that looks something like this. So it looks like we have a couple of whole numbers that we can use. But to be sure, let's go to our table. So go second, table. We're looking for where the y value equals 0. So notice that happens at negative 3 and at positive 1. This means we can synthetically divide this polynomial by either one of these values and it should go into it evenly. My guess is most of you want to synthetically divide by a 1. A little bit easier than the negative 3. Let's go ahead and synthetically divide by positive 1. And then our coefficients are 1, negative 4, negative 15, and positive 18. You drop down the first term 1. Then the pattern is to multiply and add. So 1 times 1 is 1. Then we add negative 4 plus 1 and get negative 3. Multiply and add, so 1 times negative 3 is negative 3. Add these, we get negative 18. Multiply 1 times negative 18 is negative 18. Then add these, and we get 0. Remember, we should always get 0 since we're dividing by a number we know is a factor. So we're going to write this with 1 power less than the original problem. So instead of x cubed, this is going to be 1x squared minus 3x minus 18. So to solve, it's a trinomial, we can t-chart. So x squared is x and x. We need to multiply up to a negative 18. So this should be negative 6 and positive 3. You can cross multiply, you get negative 6x plus 3x, which does give you the middle term. We're going to set these equal to 0. So on the top row, you get x equals 6. Bottom row, minus the 3, we get negative 3. And don't forget the factor that we synthetically divided by, which is a positive 1. Part B, same thing. We're going to type this into our calculator to figure out what number we can synthetically divide by. We are given a graph that looks like this. So to be certain, let's go to our table. We are looking for where y equals 0. That happens at x equals -1. So that means we can't divide by a positive 1. We have to synthetically divide by a -1. So let's go ahead and synthetically divide by the -1. The coefficients are 3, 19, 4, and -12. Drop down the first term. Multiply -1 times 3, it's -3. 19 plus -3 is 16. -1 times 16 is -16. 4 plus -16 is -12. -1 times -12 is +12. -12 plus 12 is 0, which is good. We know that we did this correctly. So to write it as a reduced power, instead of x cubed, it's going to be x squared. So this is 3x squared plus 16x minus 12. So to factor the trinomial, we're going to t-chart. So for 3x squared, that's going to be 3x and x. Then we have to multiply up to -12. So it's either going to be 3 and 4 or 6 and 2. In this case, it has to be 6 and 2, where the 2 is negative. When you cross multiply to check, 3x times 6 is 18x. And then we have minus 2x, which does give us our middle term. So to solve, we're going to set each of these factors equal to 0. On the top row, we would add the 2 and divide by 3, getting positive 2/3. In the bottom row, we have to minus the 6 over, so we get -6. And don't forget the number we synthetically divided by, which was -1.